Um, Find the inverse function and relations. We are work with graph. This kind of class belong to calculus, but we have to write. We have to answer this main question. The graph below shows a function. It is inverse also a function. That's the question. It is inverse or also function. I mean, it's this is a function, and then it is inverse function, and then or what kind? The problem we have here: relations or function. Remember, with two different things. The function. A function is a different from relations. Relations. In this graph, I'm going to show you what is the relation and then what is the function. For example, in the first graph, this graph below shows a function. This is a function, all right? But it is inverse and also a function. To know that, this is very important. If a horizontal line intersects this function, horizontal lines, in more than one point, then its inverse is not a function. The horizontal line, you trust horizontal lines. Look at this. I'm going to do that. The horizontal lines like this. Horizontal lines touch the graph in more than one point. Then the inverse is not a function. In this case, I did the horizontal lines and then touch only one point in the graph. Then this graph show that it is inverse and also it is a function. So here your answer must to be yes. All right, yes, we are going to write yes. This is a function and also it's inverse. It is inverse also is a function. All right, let's go to the second problem. We have this graph here. So, like I told you, I'm gonna show you the difference of when it inverse is a function, and then when the inverse is not a function. It's a relation. All right. Here I'm gonna trace the horizontal lines. Make the trace horizontal line right here. See the horizontal line there? You see? Then this graph. This function is not, it is inverse. This function is not a function. It's a relation because the line, the horizontal line, touch one or more point, right? Then it is inverse is not a function. Okay, it is not a function. This one. So here you have to write no, right? So let's do another graph. Let's make another graph different to this one to show you more exactly when the function it inverse. The function is a relations or a function. When it's inverse is not a function. Let's make a graph like this, for example. This one. Let's do this graph like this. Okay. Look at this graph. The first, we have to make a horizontal line. If horizontal line touch one or more point in the graph, then it is inverse. Inverse is not a function. Here is not a function. Inverse. The inverse is also a function. Here is not a function. No. So no. Here is no. So let's try to show another function. For example, here let's make another function, another graph. Let's make another graph here, and this let's do right here. Let me try it from here. On this point, let me do one graph like in this way. like this. Look at this graph. Look at this graph. What do you think? The graph below this shows a function. Okay, it is a function, but its inverse is also a function. Yes or no? Try the horizontal or drop the horizontal, drop a horizontal line like this. So you see what you see over there. So this horizontal line, how many points touch? Only 1 point. It's not more than 1 point. Then this is yes, right? Yes. The graph below shows a function. It is inverse, also a function. Yes, it is a function. The inverse also is a function. Okay. Here in this graph, for example, the graph below shows a function. Okay, show a function. All right. Period. It is inverse, also a function. Here, this first graph. No, it is not. It is inverse. It's not a function. Okay, it's a relation. It's a relation. Okay, in the second graph, this graph below show a function, right? It is inverse, also a function. Yes, right? Got it? Here, our class of today is only trying to see or find the inverse from the graph, finding from the graph inverse function and relation. So this is a relation, the inverse is a relation, it's not a function. This, of course, this inverse, it is a function, all right? Maybe I would like to write some concept here. Let me erase it and write some main idea or the conclusion. So write the conclusion. If, for example, if a horizontal line, okay, the horizontal line intersects it's right here. Sorry, intersect. All right, intersects function. Intersect a function in more, okay, in more than 1 point, than 1 point. Okay, listen to me. Then it is inverse. Then it is inverse. Right together. It is inverse. All right. It is inverse. Is not a function. Right? That's the one. Another idea. If, write everything. If no horizontal line intersects function. It's a function in more. Look at this. Here is in no horizontal. Is a horizontal line. An intersect function in more than 1 point, the is inverse. Okay, the inverse or I mean more than 1 point, it is inverse. It is inverse is a function. What I mean that almost the same, right? See, like the graph before I show you, if the horizontal line intersects the function in more than 1 point, then the inverse is not a function. Remember, when you have the graph like this, right, and then you no, in this way, right, and then you drop the horizontal line. So it is not a function. The inverse is not a function. When the graph is in this way, for example, and you try the line in horizontal way, the horizontal line, to draw the horizontal line, this is yes, right? This is no, right? There's something this show this concept. Okay, guys, so thank you so much. Waiting for you next time.